Hey guys, I'm back again with another brake light strobe video. I got the project officially finished and installed in my car, but in doing so I had to make several changes to the circuit board, so I'm going to kind of just walk through it and let you guys see what I changed, and then I'll put the new schematics in a link in the description and update the old link for the first video. That way anybody kind of coming into it knows exactly what's going on. So again, I'm going to start with a simplified circuit just like the last video and kind of explain exactly what the functionality is while hiding some of the more complex discrete components. So this is the simplified brake light blinker circuit. So here you have the 5-volt regulator, you have the two timing capacitors, and then those are connected to Schmitt triggers. If you don't remember what a Schmitt trigger is, it basically takes an analog input like this and can convert it to a digital output like this. The way it does this is using a bunch of transistors. It basically makes a comparator. That way when the input goes above a certain threshold, then the output gets pulled to the voltage reference, and when the input goes below a certain threshold, then it gets pulled to the lower reference. Then that's connected to this NX OR gate, or inverted exclusive OR gate. If you guys don't know what that is, then here's the truth table. Basically, it's only one when the inputs are the same. So 0, 0, and 1, 1. Whenever it's 1, 0, 0, 1, then the output is 0. And the way that kind of functions in the circuit is that basically, initially, the inputs are 0, 0, and that means the output is 1. Which means current is flowing through this transistor and activating the coil. When the first capacitor gets charged, then that turns that 0 into a 1, so now it's 1, 0, see here, and that turns the output to a 0, which means this drops all of the voltage, so that's going to be 5 volts now. No current flows through it, and the coil shuts off. Then, so at the same time, the first charging capacitor allows the second charging capacitor to start charging. So basically, before this, when this transistor is off, it acts as kind of an infinite resistance, blocking all current flow going into this RC circuit down here. Once this transistor is turned on, then all the current can flow through the transistor and start charging this second capacitor. That's charged, it activates a second Schmitt trigger, which comes in and changes this input from a 0 to a 1. So now the input is 1, 1. So it's this one. So the output then changes to a 1. Current flows through the transistor again, down here, goes through the coil, and then goes to ground, turning the contact back on. The important thing that I learned here is that the contact current rating is really important on the relay. If you have a contact current rating that's too small, then you end up either welding the contact shut or blowing the contact apart into like two pieces, so then your contact won't work. The way that this happened in my car, initially I put in a 1 amp relay, and when I finally got the circuit to run, it welded the contact shut like this. So basically, whenever you step on the brake pedal, the current just goes straight out to the taillights, and there's no strobing at all. But there is strobing because the circuit's still functioning and is trying to pull this relay right here. But since the contact is welded shut, then it doesn't make a difference. Nothing happens. Initially, I had a small transistor here, a small like a 2N 222A. But apparently those can't handle 6 amps of current. So I tried another method where I tried 5 SM8050s, which can take about 1.5 amps a piece. But that also exploded in my face. So then I turned to the relay and decided to use that instead. The relay does a really excellent job of separating the 5-volt signal from the 12-volt line completely. You could also probably do this with a FET, but the FETs that I have are really leaky and they don't really work very well, so trash the idea. That's kind of everything here. Next I'm going to kind of show you kind of how to install it in your car and how we're going to figure out what your contact current rating needs to be. So here you have your brake pedal, and on my car it has a little sensor up here that has a little brake line coming out of it. It's black and white, and then that goes directly back to the taillights, which then goes to ground. In older vehicles, you know, like the pre-2000s or maybe even the early 2000s, I had a 2001 Buick that had a mechanical analog system that kind of just, when you step on the brake, it actually goes directly back into the master cylinder and controls the brakes. On that case, you're going to have to go and figure out from either your Haynes manual or your owner's manual and figure out where the actual brake line is, the taillight brake line, not your actual brake line. Where it's at in your car and what color it is, and then try to find it as close to the source as possible. That being because you're going to cut this wire in half and turn it into two contacts. The upper contact here is going to be your brake signal as indicated in the schematic, and then down here is going to be your signal out as indicated in the schematic, and then this will be your ground as indicated in the schematic. So in order to find your current contact rating, what you need to do is you need to take an ohm meter here and basically measure the resistance across here and here. In my case, it was 2 ohms, which means that this light right here takes 2 ohms of resistance. Your brake signal operates on a 12 volt system, so when you step on the brake pedal, it sends 12 volts through this line and then to your brake lights. So to figure out how much current that is, you gotta remember Kirchhoff's voltage law, so V equals IR, and in this case the voltage is 12 volts that's coming from your brake line, and then we don't know I, and R in this case would be 2 ohms, but R is going to be whatever you measure from that multimeter there. So in this case, you just divide by R on both sides. So you get 12 divided by 2 equals 6 amps. And it's important to remember this number is going to be unique to whatever car you're working on. But so you need to get a relay that has a current rating of at least that number. So 6 amps or above in my case. So I got one that has a 16 amp current rating. It's also handy if you get a relay that has a high this is it, the one that I got says it's high inrush current capable. So basically when the contact, what's going to happen is you're going to send a signal through the coil, and that's going to create an inductive magnetic field that's going to come up and pull down this contact down here. When that contact makes contact with the contact, when that strip makes contact with the contact, then what's going to happen is going to be a large inrush of current, and that's actually going to create another magnetic field going around this, which might interfere with the magnetic field coming from the current, which would push the contact back up again. And then once that breaks off, you'll have the inductive disc kickback that'll fly through here, and then the magnetic field will try to pull it down again. Once the field dissipates, pull it down, makes another magnetic field, pulls it up, pull it down, up, down, up, down, up, down, up, down, and you'll get kind of a strobing effect whenever you try to turn on the relay. In more heavy-duty relays, this isn't really much of a problem, but we're trying to put a relay on a circuit board, so you're probably going to run into issues like this trying to use a weeny little relay that isn't made to do that. Alright, so then once you get this number calculated, what current you need for your relay, then you just hook your box up with the brake signal to the brake signal, the signal out to the signal out, and then the ground to the ground. The way that I found the ground in my car is basically you take a ohm meter again, or a diode checker, and I just connected one lead to a bare metal surface in the car, and then I connected the other lead to ground. I started probing around in the wires underneath my dashboard. Preferably, start with the black ones that kind of make sense. Or you can look at the actual electrical schematic and find some sort of connector or something that has a ground cable connected to it. Or you could just solder a new connection to a bare metal surface yourself. It doesn't matter. The quality of the connection doesn't really matter, just as long as you have a ground connection. After that, you're pretty much golden. It's just those 3 lines. One thing that I did differently in my car is that I actually put a single throw dual pole switch. So basically you have one side that's going to connect to the signal coming from your brake, and then the 2 outputs, the normally open one, the normally closed one is going to connect to your signal your brake signal on your box, and then the other one is going to connect to your out on the output of your box. And this just makes it so that way you can turn on and off your brake signal as you please. Basically, this gives you a way to turn on and off the strobing effect on your car. So in case your circuit explodes or your shorts out or something, if your circuit shorts, you remember that the regulator, the LM7805, automatically shuts off if there's a short, so you don't actually need to fuse it. And there's no reason to put in a fuse. Your line is already fused, and if you put in another fuse, you're basically just going to be putting in a second fuse just as big as the first one, and it's kind of useless. But if there was a short inside of this box, or this box tried to pull too much current, then that LM7805, the little 5-volt regulator, will automatically shut off, and then the 5-volt system will go down, which will turn off all the logic, and it'll shut off the output of the thing. If something like that happens, then you can flip this switch down, and then you basically have full brake power. You have full brake light ability again. You just flip it on, flip it off. You have it on most of the time, but if you have electrical malfunction, then you can flip it off if you need to. In my car, there were like handy dandy. It has a bunch of these little squares over on the side of the dashboard, and I just popped this one out and then put in a little switch. And if you don't have anything like this, you can always just drill a hole and then put in something, or I'll leave that part up to you guys. I'm just letting you know that it's important that you have some sort of safety factor here in case that your electrical circuit malfunctions in the future, and because you don't want to drive around without brake lights. So you can flip this system on and off in case that relay breaks, or whatever. But other than that, yeah, it pretty much just works when you put it in. You get the brake signal and then the signal out and the ground, and once you get those wired up, everything will start working perfectly, as long as you follow the circuit that I'm going to show you next, which is the actual circuit I'm using. We're back here again. I got the non-simplified circuit. That way you guys can kind of see everything that's going on, and if you want to build this yourself, this will have all of the correct resistor values and stuff in there with it. So you got the 5-volt regulator up here, which goes into the 2 timer circuits. You notice that the disengage is taking off from the previous video. I wasn't able to use it, and it didn't really serve any purpose, so I just removed it from the schematic as well. Then that goes down, and you have the first Schmitt trigger here, and then the second Schmitt trigger here. They have identical resistor values, so you don't need to worry about the not one having the resistor values written down. You just use the ones from the previous. Those come out, and then they go into these 8 diodes here. If you don't understand why, then the output of these 2 Schmitt triggers, even when it's low, is about 1.5 volts. And for some reason, the diodes in this circuit configuration only drop about 0.2, so we needed 4 of them to get rid of everything. And that goes through the 10K resistor into the inverted exclusive OR gate, and then that goes out to this little transistor here, which basically takes the 12 volt and then puts it through the relay. The reason, okay, I measured this point right here, and it measures 12 volts, but even when this is open, this point right here only ever measures 5, so just go ahead and do it that way and I'm sure it'll still work. Another thing to note is that I swapped out this resistor. It used to be like a 2N222A, but now it's an SM 8050, which has a massively higher collector current maximum rating. The collector current on an SM 8050 is 1.5 amps, and the collector current on a 2N222A is like 0.2, something like that. It's really weenie. And to drive a relay coil, it requires a substantial amount of current, so I swapped them out so that way it didn't burn it up. Another important thing to note is that this resistor right here needs to match the impedance on your relay coil. The way that I did this is that I basically took a potentiometer and I just used the wiper arm to connect to one side, and then the other end of the resistor I connected to the end of the potentiometer. I just used like 5 kilo ohms. Basically, you just start pressing on the brake pad while you're pressing on something. You know, turn your circuit on and off, on and off, and on and off. And while you're doing that, slowly turn down the resistance on the potentiometer until you get the relay to actually activate. Then you just take the potentiometer off and measure the resistance between the one lead and the other lead, and that tells you what value of resistor you need in here, right here. It's important because I don't remember exactly. Don't at me. It just doesn't work. So you have to turn down the resistor value until you can get the relay to trip. Once you do that, then everything will work as planned, and then you can install it. This is the new brake strobe light circuit that I created. You can see here we got a new relay. So I got another test LED set up here. These are just a way for me to be able to test the whole circuit under load. So this is 4 amp power load, and that was because the only power supply I have can only put out 4.5 amps, so I only did 4 amps. But ideally you'd want to put in like another 2 resistors here and make it a nice 2 ohms. Then that would drop an even 6 amps. Then I also have this LED here that'll test it. So the steering wheel here, so you can see up here, so right there, that's my brake. You can see it hooked up to the brake pedal down here. Goes up, follow the thing, and you see there's the brake sensor. And then this line right here is the line going out to the taillights. I just took that wire and cut it in half. Then I stripped both ends, put one alligator clip on the output of the brake pedal, and then one going back to the thing. Then I needed to find a nice ground, which turned out to actually be quite a challenge because the brake pedal itself does not actually have a ground on it. So I had to go and find another ground, which I ended up finding on one of the big fat cable connectors back here. Yeah, there's a big fat cable connector it plugs into. Yeah, you do need a ground connection because the black wire of the box here, right here, needs to connect to ground. So it goes through the green wire there and hooks up to the black alligator clip going up into the car. And then for a functional test here, if I step on the brake pedal, I can't exactly show you the taillights working yet, but I have a clip after this that does. So if I press on the brake pedal, then your light turns on and strobes once. You take it off, put it on. Yeah, you hear that relay super loud, but that's because it can handle the 6 amps of current. So you might have to compromise a little bit on the sound versus the amperage quality. So, yep. And here is the functional demo. I got my dad up there pressing on the brake pad, and this is the taillights of the car. Alright guys, so that's going to wrap it up here. You can find the schematic down in the description, or if you have any problems, you can always hit me up. Just leave a comment, and I'll get back to you with any solutions that I find. And with that, remember to hit the subscribe button, hit the bell icon, because I think I'm going to try to keep doing projects like this to kind of keep myself entertained, and they're really interesting. So, yeah, see you later.